Warm greeting and wishes to everyone. Today we are going to see about the video lecture on the reinforcement concrete of the working stress method of design. The working stress method of design consists of three major parts. Either you can design as a balance section, and the second one we can design as a under-reinforced section, or the third one you can design as a over-reinforced section. So out of which the best method is you can design as a balanced section or under reinforced section. You should not design as a over reinforced section. What is the reason behind it? In the case of balanced section, both concrete as well as the steel will reach the yield stress. In the case of concrete, the crushing strength, and in the case of steel, the yield stress in the steel will reach simultaneously. So here, the critical neutral axis is coincident with the actual neutral axis. The critical neutral axis will be the for a balanced section is coincide with the actual neutral axis. So in the case of under reinforced section, what will happen? We are providing the steel in a which is less than what is required for the balanced section. So due to this, what will happen? The yield strength in the case of steel reaches more and the failure will occur before the concrete crushes into a failure. So the yield strength of steel is having a more ductility, so that means it gives a lot of time to rectify the error so that the living being can be evacuated before the failure occurs. So it gives enough time to evacuate or for the safety of the structure before the failure occurs. So here the critical neutral axis is for the balance section, and the actual neutral axis will shift above the critical neutral axis. So that means what? The actual neutral axis I call it as x suffix u, and the critical neutral axis I call it as xu max. So here xu max is greater than xu, or in terms of xu is less than xu max. So that means the yield strength of steel occurs right before the failure occurs. The concrete is safe, so it gives enough time. So it is a very good design. We can use it for a under reinforced section. But in the case of third type, that is over reinforced section, the critical neutral axis for the balance section is at a central point, that is the centroid of the balance section. But here, in the case of over reinforced section, what will happen? Because of the amount of the concrete is more, what will happen? The neutral axis will shift below the critical neutral axis. So what will happen? Here, the actual neutral axis is greater than the xu max. The critical neutral axis is less value. So here, so xu is greater than xu maximum than compared to the under reinforced section. So sudden failure will occur in the case of concrete reaches age, the ultimate strain. So what will happen? The crack will occur, suddenly it will fail, so it will not give enough time to rectify the mistake, or the people have a very good in the case of safety is less. What will happen? The sudden failure will occur, so something will happen to the living being also. So it is a sudden failure in the case of over reinforced section. You should not design in any case as a over reinforced section. You can design as the best thing as under reinforced section, or you can design the second best thing is balanced section. So the failure will occur both in the case of steel as well as the concrete. That is called as a balanced section. So here in the case of under reinforced section, right, the failure will give in the case of yield strength more in the case of a steel, so it give enough time and to rectify the things in the structures. And in the case of over reinforced section, here xu max is less than xu, that is the critical neutral axis is less than the, the actual neutral axis depth. So you cannot design in any case as a over reinforced section. This is called as the balance section, under reinforced section, or over reinforced section. Either you can design as under reinforcement, that is the best method, or you can design as a balance section. Never you should not design as a over reinforced section. So this is the three types in the case of working stress method. Nowadays, the working stress method and ultimate load methods are, in the case of RCC structure, is obsolete. We are designing in the case of using the limit state method as per the IS code and other methods. So in olden days, they have used the under enforced section, or in the case of balance section, for a working stress method. So in the case of working stress method, the safety factor for steel and concrete more. So for the concrete, it is around 2 to 4, and the case of steel, it will coming as 1.5 to 1.75. So it is not an economical method, but in the case of the limited method is a more economical method compared to other two methods, and also a safe method, and also IS had given, IS 456 given all type of design in the case of limited method. So in the modern days we are using internationally about the limited method only. So here they have used the partial safety factor for concrete as well as steel, and all the sulfide, and also the dead load, as well as for the wind forces. So that is the modern technology used internationally. That is about the limit state method. Thank you very much for the introduction of this working stress method of balance section, under input section, and the over input section. Thank you very much for patient listening. God bless. வாழ்க வையகம். வாழ்க வளமுடன்.